Okay, we're going to be doing the homework from 6.1.4. So let's get down to the bottom. Here we are. Homework. When Mrs. Shreve solved an equation in class, she texted her solution and did not make the equation true. Examine her work below and find her mistake. Then find the correct solution. Okay, so it looks like what she did is she had this equation and she distributed. So the 5 times 2x has to be 10x, so that's good. Then the 5 times the negative 1 has to be negative 5. So, so far so good. Now, I am going to write the steps that she did to illustrate what happened. So she distributed the 5. She distributed the 5. Next, she combined like terms between the 10x and the minus 3, so we'll go with that. And 10x minus 3x is 7x, so that worked fine. So we'll just say that she combined like terms, and that got this, and that's all legit too. And now it looks like what you would do, you'd subtract 5x from both sides, which would get rid of it on the right side, but it seems like what she did actually is she subtracted 5x on the right side but added 5x on this side. So you should subtract 5x both sides, and we'll put that in pink to, of course, show that that's the step. And so here's the error. She got 12x because she added on one side while subtracting on the other. She should have gotten 2x minus 5 is equal to 9. Which would have taken her here. So that's the incorrect step. Instead, what she should have done is add 5 to both sides. So we'll just go with that. She needs to add 5 both sides. And what that's going to get is 2x equals 14. At which point she would divide by 2 on both sides. Which would get her x equals 7. And that would do it for this problem. So the error again happened when she failed to subtract 5x from both sides. It should be 5x with no space. Okay. 41. For this sequence, 5, 25, 125, 6, 25, what kind of sequence is it? Well, it's multiplying by 5 every time. So it's an arithmetic sequence. And all that means is that you can do arithmetic to show how the sequence works. So if you're just multiplying by 5 every time, it's an arithmetic sequence. Not a big deal. If you figured out that it's multiplying every time, that's fine. So what is the fifth term? Well, if the first term is 5, then we got 5. So this is the second term, third term, fourth term. So basically, if we're multiplying by 5 every time, we'll just multiply by 5 one more time. So 625 times 5, anybody? I get, off the top of my head, 3,125. 600 times 5 is 3,000, and 25 times 5 is 125, so 3,125. Write an explicit equation for the sequence. Okay, if the first term is 5, and then it's going to multiply by itself every time, basically, then y is equal to 5 to the power of x. In other words, for the first one, when x is 1, it's 5 to the first power. And for the second one, when x is 2, y is 5 to the second power, or 5 to the power of x. When x is 3, y is 125, because that's 5 to the power of 3. So it is 5 to the power of x, just like that. All right, 642. Which line below is perpendicular to y equals? All right, it's confession time. Part of this problem did not show up, so if you've struggled with it, it's very understandable. Let's take a quick look here. Trouble is that 2/3 did not show up in the problem. So I'm going to go back here. Oops, sorry. I'm going to go back here. Perpendicular to negative 2/3 x plus 5. Really, there's nothing you can do. It's my fault. But if we have this, we can figure it out. So that 2/3 was missing. You can insert it. Perpendicular. We know that perpendicular lines have negative reciprocal slopes. I'm going to start just by writing that. Perpendicular lines have negative reciprocal slopes. Or you could say opposite reciprocal slopes. In other words, if the slope here is negative 2/3, then we need the reciprocal of that, which would be positive 3/2. So we need m to equal positive 3/2. So, well, unfortunately, none of these are in slope-intercept form, so we can't instantly identify the slope. So we need to convert these to slope-intercept form. So we do that by isolating the y. So let's work on getting y alone for each of these. That's familiar. What we'll do here is we'll subtract 2x from both sides. And what that will get us, first of all, is negative 3y is equal to negative 2x plus 6. And then we will divide by negative 3 on both sides. And what that's going to get us is y equals, watch this, negative 2 over negative 3 x plus 6 divided by negative 3. Okay. If we take a look at this slope, we have negative 2 over negative 3. The problem is the negatives are going to cancel out. So our slope on this one is 2/3. We need it to be 3/2. That's not going to work out. Also, a positive divided by negative over here will turn into a negative. And then we can do 6 divided by 3 is just good old-fashioned 2. So that doesn't quite work out. We have y equals 2/3 x plus negative 2. We need to have a slope of 3/2, not 2/3. So that's not working out too good. Let's try this one. I'm trying to get a slope of positive 3/2. Same thing here. We'll subtract 2x from both sides. Because again, we're trying to get y alone. So the same thing here, except for we're going to have everything's the same, except for we're going to have positive 3y instead of negative 3y. So I can do this. 3y equals negative 2x plus 6. So this time when I divide, I'm going to divide by 3 both sides, and that's going to get us y equals negative 2/3 x plus 2. and that still doesn't work. We're looking for positive 3 over 2, so this one actually has the same slope as the original one, so this one would actually be parallel to this line. They'd be parallel because they have the same slope. Lines with the same slope are parallel. We're looking for perpendicular. Again, perpendicular slopes are negative reciprocals of each other. Okay, this one, trying to get y alone. This time we're going to subtract 3x from both sides. And that's going to yield negative 2y is equal to negative 3x plus 6. And then what we'll do is we'll divide by negative 2. And what that will yield is y equals, first we're going to have negative 3 over negative 2 x plus, and then we have 6 divided by negative 2. Alright, and simplify this. We have negative 3 over negative 2. Negative divided by negative is positive. The negatives cancel. Also, we have 6 divided by negative 2, which, you know, a positive divided by negative is negative, so it's negative. 6 over the 2 simplifies to the 3. But the main thing here is we have the slope that we're looking for. Positive 3 over 2, which is the negative reciprocal of this one. So this one looks pretty good. I'm going to save that. If we do the same thing here, of course we would start by subtracting 3x from both sides. So that would be exactly the same. It's always good to solve everything, even if you think you have the answer, just to make sure that you haven't made a mistake. So we get exactly the same thing, only we'd have positive 2y equals negative 3x plus 6. So that would be the same, except for the negative would be gone because here it's plus. And when we divide, we'd be dividing by positive 2, not negative 2. And what that yields is y equals negative 3 over 2 x plus 6 divided by 2, which is 3. So this has the negative slope. The one we're looking for is this one. So it's 3x minus 2y equals 6 should be perpendicular to this. So if we remember what perpendicular means that they are a 90-degree intersection to each other. This sounds like a job for Desmos to prove whether what we've come up with is accurate or not. So what I'm going to do is I'm just going to copy and paste our two equations, and they should make a 90-degree angle against each other in Desmos. And if they do, then we know that we're doing it right. So there's this line. That's our starting one. And then our new one, I'm not going to do my solution one because I might have made a mistake. Instead, I'm going to do the original one in standard form because that's the way it was given. And if that is perpendicular to our original one, then it is. And look at that. That's a 90-degree angle. You can hold up the edge of a piece of binder paper to that, and it'll fit perfectly because that is exactly 90 degrees. It's odd that we have a really strange solution point between the two lines, but it's not really relevant. All that really matters here is that they make a 90-degree angle. And again, we were able to prove that by taking these, putting them into slope-intercept form, and finding the one whose slope, 3 over 2, is the negative reciprocal of the slope of the problem that we started with. And there you have it. Thank you very much.